Right guys, let's have a go at page 22 then. We've got 13 part A, part 1. Factorize x squared minus 64. Notice that 64 can be written as a square number. It's 8 squared, isn't it? So we can write it as that, and then when you see that, the nice thing is you can just write the difference between two squares. It's something you should be able to spot straight away, really. So the first term will be x squared, the last term will be 8 squared, which is 8 times 8. And then to get the minus, you just put one of them as a plus and one of them as a minus. Now let's check if that's right. We've got x squared, the first line, plus 8x minus 8x. Right, they cancel each other out, don't they? And then the last term will be minus, plus times a minus is a minus. 8 8's a 64. So you get the x squared minus 64. So there we are. Doesn't really need much more of an explanation than that, because it's a standard thing, difference between two squares. Now let's move on to part 2. So with that thought in mind then, we can write the top part of this fraction, polynomial fraction, as x minus 8 times x plus 8 in brackets. Underneath we need to factorize this quadratic here, so let's draw the brackets. The first term corresponds to this position times this one. It's 2x squared, so I can put in 2x and x without further ado. So that's okay, isn't it? 2x and x. Now the last position is 8, with the middle term being minus 15. So if I could put an 8 and a 1 or 4 and a 2, but I notice when I think of 8 and 1, I think 2 8's are 16. That's very near to minus 15. So I'm very tempted to put that and see if that works. So let's try it. So it would be 8 times plus 1, wouldn't it? So let's see what we got. We got 2x squared. Then we noticed the 8, the last term, was 8 times 1. And we noticed that if I put the minus there, the 2 times minus 8 will give minus 16, which is really, really close to minus 15. And then we can just add the plus 1, which will make minus 15. So that looks like it's fine. As I say, that was a thought process. Let's just check it then. 2x squared, first term. Second term is minus 16x, and the third line is plus x. Minus 16x plus x is minus 15x, which is that term there. Great. And then the last line, which is this product here, is plus times a minus is a minus. 1 times 8 is 8. So that's it. That's good. Now you'll notice there's a common factor top and bottom, so we can cancel those, divide by the common factor, and we get x plus 8 over 2x plus 1. Yeah, that's it. That's the answer for number 2. So let's move down then to the next one. 0.823 recurring. The 2 dots mean 2, 3 recurring. So if I write x is equal to 0.823, right, then the first thing to notice is if I do 10x, let's times it all through by 10 and you'll see what happens here. You get 8.23 recurring, agreed? Yeah, and that was 10x, wasn't it? Now if I do 100x, so let's do 100x, or 1000. Yeah, let's do 1000x, sorry. 1000x. That means we're going to move this forward times by 1000, you move it forward 3 times, so it's 823. And then because this is recurring, the 2 3 repeats here as well, doesn't it? So let's put the recurrence here. Alright then, so you can see why we've done that now, can't you? If we move times it by 10, we just get 8.23 recurring. This is 1. If we times it by 1000, the 823 comes over through the decimal and it's moved to here. And we get 823.23 recurring. And the nice thing is now, if we make the difference, this decimal part will disappear, won't it? So let's do 2 take 1 then. 2 minus 1 gives, so it would be this take that, which is 990. X is equal to 823.23 recurring. Take away 8.23 recurring. 823 take 8 is 815.0. So it's 815, isn't it? So straight away now then move the 990 from times down to divide. And you get what x is, 815 over 990. So it's a matter of remembering, there's the answer. Remember that little trick. We can shift this recurring decimal forward. And we did that a couple of times. We times by 10 and got 8.23 recurring. Then we times by 1000 this original thing, and we got 1000x is 823.23 recurring. And then we saw, oh, the differences now, and that will get rid of this awkward decimal here, and we can solve for the x. which is what this thing is, because we need to write that as a fraction, don't we? So we get 990x. Take that as 990x. 1000x take 10x is 990x. Then you've got 823 point this decimal here. Take away 8 point the same decimal here. So when you take them away, these will cancel each other out. And you're just left with 823 minus 8, which is 815. Yeah? Over 990. Good, that's that one done then. So let's go on to the next one without further ado. Evaluate root 72. Now, and you've got root 2. And the best way to do this is to look at it, not just blindly try and expand the bracket, but have a look at, take a moment looking at this first. You see the root 72 is going to be root 72 is equal to root 36 times 2. Yeah? And you can use the property of square roots where square root of this times that would be the square root of the first thing times the square root of the second thing, won't it? And that's equal to square root of 36 is 6. So you've actually got 6 root 2. So that will make life a lot easier if we do that then. So let's replace root 72 by 6 root 2 minus the square root of 2 squared. 6 root 2's take away 1 root 2 because that's what we've got here. By default it's 1 lot of root 2. We don't usually write the 1 lot of. That's what we mean when we say root 2, 1 lot of root 2. So 6 root 2 take 1 root 2 is 5 root 2's, isn't it? That's squared. So that would be 5 root 2 times 5 root 2. Let's write that down explicitly. 5 times root 2. So that would be 5 times 5 times root 5 times root 2 times 5 times root 2, which is 5 5s are 25. Root 2 times root 2 is just 2, of course. And so the answer is 50. There we go. That's part C done. Good. Takes a moment. If you didn't notice that, then you just have to expand that blindly and just try and work it out from there. But this is a handy little thing to know. Same goes here, learning that little trick as well. Okay then, that's this one done then. That was page... let's have a look. Page 22. So that's that one done. Good. Let's go on to the next page.